There is a feeling that almost everyone knows who delves deeper into Apollo for the first time. Not necessarily doubt, more like a sense of irritation, and I have followed up on this irritation, especially since Tim Dodd released his video about it. What I discovered was truly astonishing. That's why it's worth revisiting this topic. This video is for nerds who usually hang around here on Mars Chronicles. But it's also for you if you've ever wondered who filmed the ascending lander. But also for those who believe that you can't get through Earth's radiation belt without getting fried. Or that the space capsules would in no way be able to keep people alive in space. And the interesting thing is, if you put all these arguments aside, radiation, technology, physics, politics, what often remains in the end is something much more trivial. Not a calculation error or contradiction in the data, but an impression, a gut feeling, an irritation, as I said, that you can't easily put into words. And it's exactly this feeling that makes many more people start to doubt. The images seem strangely too calm, too clean, not dramatic enough for something that was supposedly one of the greatest technical achievements in human history. No thundering science fiction spectacle, no bright colors, no heroic soundtrack, just gray dust, slow movements, and astronauts behaving as if they're sorting a tool cabinet, not standing on a foreign celestial body. And this is exactly where the problem begins, because our brains are not good at judging history. But it is excellent at creating expectations. We grew up with computer-generated imagery with quick cuts, with cameras that show every explosion from 5 different angles. Apollo, on the other hand, looks like a bureaucratic procedure. At a time when computers had less computing power than a calculator, when engineers didn't simulate problems, but calculated them with paper, tables, and slide rules. Three stages, 5 F1 engines at the bottom. Just one of them had more thrust than entire rocket programs of other countries. If you visualize it, like I do here in this cutaway, it becomes clear. Who would believe that all of this was simply filmed? They're not just underestimating the technology, they're underestimating the industrial and organizational machinery behind it. Another problem, we systematically underestimate how quickly technology develops. In 1961, the first American flew suborbitally, and in 1969, humans landed on the moon, 8 years later, and not even 70 years after the first flight by the Wright brothers. Today, it takes us 8 years just to renovate an airport or to get a rocket through an environmental review. Our sense of time today no longer fits that era. The Cold War was not a normal environment for innovation. It was a state of emergency. Unlimited budgets, political pressure, and existential motivation. It's not about profitability, but about whether we're faster than the Soviets in the next few minutes. That's why we're not going to look at what feels right, but at what is measurable, verifiable, and still visible today, the traces on the moon. Measurements that are still ongoing today, and physics that can't be negotiated, no matter how loudly someone shouts on the internet. Because if Apollo was a staged event, then it is the most elaborate, internationally verifiable, and still functioning deception in human history. And all of this is also because Apollo wasn't just a round trip, but a complete mission architecture, as you can see here in this graphic behind me. It doesn't show a single event, it shows a system, a choreography of physics, timing, and engineering. And you don't fake systems of this magnitude. They either work or they blow up in your face. I'm Serwan, and this is Mars Chronicles. Let's take off. Traces that don't disappear. If Apollo was just a movie, then it's a remarkably bad one, because good forgeries disappear. They can't be checked anymore. They don't survive generations. Apollo, on the other hand, leaves something very inconvenient for conspiracy theories: permanent, measurable traces, the mirrors on the moon. Let's start with perhaps the most elegant pieces of evidence in the history of space travel: the lunar laser-ranging retroreflectors. Mirror arrays were placed on the moon during Apollo 11, 14, and 15 missions. No electronics or power supply, just precisely aligned glass prisms. Their purpose is simple and brutally honest. A laser pulse is sent from Earth to the moon, it hits the mirror and comes back. The travel time is measured 2 ways at the speed of light. The result? The distance from Earth to the moon can still be determined to the millimeter today, and you can do this from home. Not even exclusive to National Aeronautics and Space Administration, these measurements are carried out by observatories worldwide, in the United States of America, in Europe, in Japan. If the mirrors weren't up there, there would be no echo. And this is where it gets interesting. These measurements show things that can't be faked. The moon moves about 3.8 centimeters away from the Earth every year, and the Earth's rotation slows down slightly. Relativistic effects must be considered, or the data won't match. That's not symbolism, that's physics, and it only works because someone placed those mirrors there. But maybe someone else brought them there. A classic. Then let's take a look at who else visited the moon. Since Apollo, the landing sites have been photographed hundreds of times by different lunar satellites at different times, with different cameras. For example, National Aeronautics and Space Administration's Lunar Reconnaissance Orbiter, but also Chandrayaan-2 from India and Kaguya from Japan. Even Chinese and Russian missions, and they all show the same landing sites, traces of the astronauts, abandoned instruments. Not as high-res as Google Maps, but matches what physics allows from 50 kilometers up. And the crucial thing, these images match each other. A global, decades-long international forgery would require more coordination than the actual moon landing, the Van Allen radiation belt. And then comes this one, probably the most persistent myth of all. Humans can't cross the Van Allen belt without getting fried. Sounds dramatic, but from a physics standpoint, it's complete nonsense. The Van Allen belts aren't a wall. They're zones of increased radiation, created by charged particles trapped in Earth's magnetic field. The 3 key factors are intensity, exposure, duration, and the flight path. Apollo didn't fly straight through the middle, but rather through the thinnest outer edges. The astronauts spent less than an hour there. The measured total dose was lower than that of a computed tomography scan. Not 0, but far from deadly. And now the most important point. Apollo wasn't blind. The missions carried dosimeters, radiation was measured, recorded, and documented. The data exists, and it also matches what we know today about magnetospheres, particle physics, and cosmic radiation. If Apollo is or was a lie, then this data would have to coincidentally match modern physics exactly. An amazing coincidence. The studio arguments. At this point, many conspiracy theories change levels. When physics, measurement data, and global observations stop being useful, then people move away from numbers and towards images, because images feel more convincing, and this is exactly where the most well-known myths arise. The ascending lunar module was filmed by someone. The flag is waving in the wind, you can't see any stars, the shadows look strange, and there's no crater under the lunar module. And then there's that one moment, the famous press conference after Apollo 11, where Armstrong, Aldrin, and Collins somehow seem strange. Let's begin with the most famous. Who filmed the lunar module launching? The video showing the ascent stage of the lunar module lifting off from the moon is considered by many as the ultimate proof of a studio recording. The camera pans along, perfectly centered, almost as if someone was operating the controls. But that's just what someone did. The camera was remotely controlled. It was mounted on the lunar rover and operated from the ground station on Earth. Not live with a joystick, but using pre-calculated pan profiles and commands with a time delay. Because the speed of light does not allow real-time communication, so real-time control of devices is also not possible. The latency is over 2.5 seconds. That wasn't magic or a cameraman left behind on the moon, that was engineering work, and it wasn't perfect. Because if you look closely, you can see that the lunar module doesn't stay exactly in the center of the frame, it drifts slightly out of the frame. That's exactly what happens when you control a camera with a delay, without real feedback. It didn't work the first time either. They needed several attempts to get the timing right, but you don't see these recordings in public very often. They probably would have done it better in a studio. The flag is waving in the wind. No, it's not waving. The Apollo flag had a horizontal crossbar so that it would look spread out at all because there is no wind. What you see in the videos are vibrations that occur when the astronauts rotate the pole or drive the mast into the ground. In a vacuum, there is no air to dampen this movement. That means the flag swings longer than it would on Earth. And that's exactly what looks windy to our eyes, but in reality, it's the opposite. An object settling without air resistance. Why can't we see any stars? Because the cameras are usually set in their exposure settings to photograph the bright lunar surface. Anyone who knows about photography understands how this works. The astronauts didn't see any stars either because it was daytime during their stay. And think about how many stars you see here on Earth during the day, apart from our sun. The surface of the moon is extremely bright, the suits are white, and the ground reflects sunlight. The cameras were set to short exposure times and small apertures to avoid overexposing everything. Stars are very dim in comparison. If you take a photo of someone at night with a flash, you won't see any stars either. Even if you could see some with the naked eye, not because they're not there, but because the camera is set for the foreground. The shadows aren't parallel, or are they? What's happening here is perspective. Parallel lines don't look parallel in the distance. Tracks converge, roads taper. It's geometry and perspective, not a conspiracy. On top of that, the moon isn't a flat surface. It's hilly, uneven, full of craters and edges. A single light source, namely the sun, is more than enough to create exactly these effects. In a studio, they probably would have lit it much more consistently. There's no crater under the lander simply because the engine doesn't work like a bomb. The landing engine had very little thrust at the end. It was throttled down and blew the dust to the side, not downward. That's exactly what you can see. The ground under the lander is clean, but all around the dust has been blown away. The lunar dust is also very fine and compact. It doesn't form nice earthy craters. Stanley Kubrick filmed all of this. That's almost a meme. If Stanley Kubrick had filmed it, it would look more aesthetic, more dramatic and cinematically thought out. Apollo doesn't look like 2001, Apollo looks like a documentary. The original data tapes were erased. Yes, that's true, and it's nothing special. In the 1970s, magnetic tapes were expensive. The videos still exist in copies, in conversions, in broadcasts. It's sloppy archiving, not destruction of evidence. Why did the astronauts behave so oddly at the press conference? Because they had just come out of quarantine, were physically exhausted, under massive media pressure, and knew that they had just made history. Not that it was still ahead of them. Neil Armstrong was never an entertainer. They didn't seem like actors, they seemed like engineers after an extreme ordeal. And honestly, if they had lied, they would have rehearsed it better. All these arguments have one thing in common. They only sound convincing if you don't know how cameras, lighting, mechanics, and space travel actually work. The real reason why this topic keeps coming back isn't Apollo, it's the present. We are once again on the threshold of the moon with Artemis, China, and private players. And suddenly, the same questions come up again. Radiation, long-term stays, energy, and infrastructure, only this time with better technology and better measurements. Apollo is not a myth, but a data set. And that data set is becoming relevant again. It's almost ironic. While space agencies are planning infrastructure, industry partners, and supply chains, part of the public is still debating whether humans can even fly through the Van Allen belt. Why doesn't this debate go away? Is it just emotionally convenient? It's easier to declare 50 years of spaceflight impossible across the board than to deal with orbital mechanics, radiation physics, and mission architectures. The Van Allen debate isn't a scientific one, it's a cultural defense reaction, because if Apollo was possible, then progress is possible. Of course, that's frightening, and here's the real point. Whether you believe in Apollo or not doesn't change the present. The moon is being developed, not because it's beautiful, but because it's useful. Resources, energy, and as a springboard to other planets. Maybe that's the most honest way to end this topic. The debate about the moon landing isn't a debate about space travel, it's a debate about trust. Not trust in National Aeronautics and Space Administration in archives or old videos, but trust in the idea that people, as a civilization, are capable of things that are greater than their everyday intuition. And who can blame the people out there who are lied to by their governments every day for thinking that they've been fooled here as well? Apollo was not a miracle, it was not a myth, and it was by no means a perfect program. It was a brutally expensive, risky, politically motivated engineering project and proof that the door is open. We didn't go through it again for a long time. Why? I explained that in another video, which is of course linked below. But now we're doing it again, and this time not for prestige, but out of necessity. A huge thank you goes out to all channel members and Patreon supporters. If you also want early access to our videos, you'll find all the information about it below in the video description. My name is Sirwan, and this was Mars Chronicles. Thanks for tuning in. Per aspera ad astra.